momentum and impulse unit assignment, the written response unit assignment. Of course, different format than we have on our test tomorrow. That's multiple choice and numeric response. The content is the same though. As I said before, what we have to do when we see those questions that are multiple choice and numeric response with context, we have to boil it down to one of these questions, because that's what they all boil down to, right? They all boil down to a simple word problem. If we can strip away those other 3 paragraphs or whatever it is that provide context to the question. If we get a question that's like this, even if it looks like it's a half a page on tomorrow's test, we can nail this. This question says a 400-gram football is thrown at a speed of 12 meters per second from a height of 1.75 meters above the ground. Determine the magnitude. The magnitude, we don't need the direction, just the magnitude of the momentum as the football as it strikes the ground. Now I'm going to circle grams. I'm going to do that on tomorrow's test as well. Everybody's going to be given a paper copy of the test. You can feel free to mark up that booklet to your heart's content. Circle things like grams. Underline, highlight, do whatever. Write down your givens on that paper. Show your work on that paper. Do it as if it's a regular problem. This is our routine of doing these questions. Keep the routine, even though they're multiple choice and numeric response questions. Keep the same routine. This is, if you remember, one of the first things that we did this year. Remember we said, I can't remember what topic number it was, but it was, 12G or something like that. Momentum after acceleration. Remember that? Day 2, I think it was, of Physics 30. Momentum after acceleration. We want to find the momentum of a football after it's fallen, after it was thrown and falls and strikes the ground. So let's write down some givens here. We have a mass of 0.400 kilograms. We have an initial speed of 12 meters per second, not an initial velocity, because I don't actually know which direction it was thrown. Thrown up, thrown down, thrown at an angle, don't know. Doesn't matter if I'm just writing down speed here, okay? Now, it's thrown from a height of 1.75 meters above the ground. That means, remember this? The displacement of this ball is, by the time it strikes the ground, which is what we're concerned with because we're looking for the magnitude of the momentum as it strikes the ground, is negative 1.75 meters. The most common mistake that people made on this is, it surprised me actually, I was expecting the most common mistake for people to not include the initial speed, to not use the initial speed. And that's what some people did, not use the initial speed. But the more common mistake was forgetting to make the displacement negative. People said negative 9.81 for the acceleration, but positive 1.75 for the displacement. It didn't end 1.75 meters above where it started, it ended 1.75 meters below where it started. So don't forget those signs, right? Now we want to find the final momentum, the momentum as it strikes the ground, or at least the magnitude of that momentum. Momentum is equal to m times v, but we're looking for the final momentum, so it's going to be m times the final velocity. Technically, because it's the magnitude of the momentum, it's m times the magnitude of the velocity, right? We don't actually need what direction the ball is going when it hits the ground. We just need the magnitude of the velocity, or in other words, the speed at which it's moving when it hits the ground. But we got to find that. So we're going to do here what most of you did on your assignment. Vf squared is equal to vi squared plus 2ad. Vf is equal to the square root of, usually vi for us is 0 in one of these questions, but remember in class when we were doing these, I warned you that there's always the possibility, including on a test, where vi is not 0, where vi is something. Make sure you include that. 12 squared plus 2 times negative 9.81 times negative 1.75. Again, the most common mistake was doing exactly what we did here, except the negative, leaving that negative off. What difference does that make? If you say 12 squared times all of this, it ends up being 144 plus a number. If you make it 2 times negative 9.81 times positive 1.75, then it ends up being 144 minus that number, which clearly gives you a different answer, right? So we're going to solve for Vf here, after I get rid of that highlighter. Vf works out to be 13.3 0.354213 meters per second. Which direction? We don't actually know which direction it's traveling. It may be straight down. It may be at an angle. It depends upon, to be honest, what angle it was thrown at. If it was thrown straight up or straight down, then it's going to be moving straight down right now. If it was thrown at an angle, then it's going to be moving at an angle right now. But because we were only looking for the magnitude of the momentum, not the direction, that doesn't really matter. All right, let's multiply that mass in kilograms, 0.400 kilograms, times that final magnitude of the velocity or speed, 13.35, etc. Gives me a value of 5.34 kilograms meters per second, or 5.34 Newton seconds. All right? If you made a mistake on that, and several people did, it's not like it was like, oh, everybody bombed that question. It wasn't that bad. But several people still made a mistake on it. That's okay. This is an assignment. And right now, that assignment looms fairly large because it's the only one that's marked and is in Power School right now. The lab that you did last week or submitted last week will be marked by the end of tomorrow. And in Power School, making this assignment seem a little bit less important, right? In fact, a lot less important, half as important as it does right now. But man, by the end of the year, it's the tests that are going to matter, right? It's those tests that are going to matter. So you're going to make a mistake? Well, the first place you're going to make them, hopefully, the place you fix your mistake is on your homework, right? You make the mistake on your homework, fix it. But if you don't fix it there, or you don't make the mistake there, make it on a quiz. The quizzes don't matter for much at all by the end of the year. But if you don't make it on a quiz or don't fix your mistake, make it on an assignment. Get it out of the way. Don't make it on the test. If you do, it's not the end of the world. We all make mistakes. We're going to make mistakes on the test. But if you made a mistake here, let's try to fix it so that you don't make the mistake when it really counts. So, okay? So that question was there too. Basically, if you did P is equal to M times V, you got a 1. And then if you made a mistake, some other mistake, you lost your other point. Okay, number 2 says a 430 gram, once again, we have this gram thing that we got to convert. Okay, I've done that several times in this assignment. That's not a coincidence. I purposely did that several times to reinforce the idea that you need to be alert for that. You need to be on the alert for grams and non-standard units so that we can convert those, right? You got to figure on tomorrow's test, if you don't convert, the answer is going to be there, right? You're going to see an answer that you got and say, oh, I got it. But, of course, whoever made the multiple choice question anticipated that some of you would forget to convert to kilograms or whatever the case would be. So just watch that, draw attention to that, circle it, highlight it, whatever, write it on your question booklet. Soccer ball moves toward a man's foot at a speed of 12 meters per second. The man kicks the ball. Soccer ball moves off with a speed of 15 meters per second in the opposite direction. I'm going to underline this or circle this or whatever to draw attention to it. Why? What's important about this? What's important about drawing attention to this? What mistake could I possibly make with this? Or at least what silly mistake, Marty? Yes. If the ball is coming towards me and then it's going away from me, we have to be aware that one of those is positive and one of those is negative. We had a question on our worksheet like that. Do you remember that? I think it was a soccer ball too, actually. I think. Where coming towards me, going away from me, one of them, doesn't matter which one, is got to be positive, one of them is going to be negative. Time of contact is 0.4 seconds. We want to find the impulse that the man's foot provides to the soccer ball and the force of impact of the man's foot on the soccer ball. So once again, I'm going to write down my givens. My mass is 0.430 kilograms. Divide by 1,000, right? Okay. Unit conversions are on your back of your data sheet. Okay, it tells you that a kilo is 10 to the 3, or 1,000. So if you're puzzled by that tomorrow, if it's like the middle of a test and you're stressed, you're a little anxious about things, and you're like, oh man, is it 100 or is it 1,000? Just check your data sheet. It'll tell you that it doesn't say 1,000, it says 10 to the 3, but good enough, right? Just check your data sheet. Now it comes toward the man's foot with a speed of 12 meters per second. I'm going to make that VI negative 12. And I want to make the speed of the soccer ball, or the velocity of the soccer ball after it moves off, positive 15 meters per second. But I could have just as easily went the other way around. How many people do you remember did that way? Who went the other way around? Okay, most people the other way around? Okay, I'll do it the other way around then, since most of you did it that way. Because it doesn't really matter. Let's make this positive and this negative then. The time of contact is 0.400 seconds. We're looking for the impulse, which is delta P, and we're looking for the force of impact as well. If we were just looking for force, we could just say F times delta T is equal to M times delta V. That works. But because we're looking for impulse, let's do it in two separate steps here. Delta P is equal to M times delta V, which is 0.430 kilograms times VF minus VI. Remember, delta P is M times delta V. Remember we talked about that as well? If you just say delta P is equal to M times V here, there's a very good chance that you're going to make delta V either 12 or 15 and not both. If you make it M times delta V, you explicitly put the delta in there, then you're more likely to remember that there's two numbers that you've got to deal with there. Negative 15 minus 12, or if you flip the signs around, it would be 15 minus negative 12. I'm going to get a delta P here of, on my answer key, I actually had positive 11.61 because I had flipped them around. You would get negative 11.61 Newton seconds here, or negative 11.7 Newton seconds. Okay. Either one is fine. It just depends upon how you define your positives and negatives. If this question is a test question, it likely would have asked you not for the impulse, but the magnitude of the impulse, most likely. Now we're looking for force of impact as well. Now that I have impulse, we say impulse is equal to F times delta T. Didn't I tell you guys you cannot use this equation? When did I tell you you can't use that equation? When did I tell you that you can't use that one? Right, if you've got a force versus time graph, which we have in the next question, you can use M times delta V, you cannot use F times delta T. Or at least you shouldn't, because it's going to lead you astray if you try. Let's use the unrounded number here, negative 11.61 Newton seconds, divided by my time interval here of 0.400 seconds. That gives me a force of negative 29.0 newtons. Or positive if you had to reverse the signs. Again, either would have been correct. And again, most likely, if this is a test question, they're not going to ask you for the force. They're most likely going to ask you for the magnitude of the force. Bottom line is, look, negative, we defined negative here as being away from the soccer player, right? Positive was toward, negative was away. We can see that my force is away from the soccer player, which should make some sense, right? If you're kicking the soccer ball away from you, then your force that you're applying is away from you. So that would be a negative number to be consistent with the way we define that there. Okay, 3. A young girl applies a force on a 75-gram toy over a period of time as described by the graph below. The toy car begins at rest. Right away I see what? Grams, yeah, I circle that, and you should too. What else? I see a force versus time graph. And every time I see a force versus time graph, I'm thinking those three words, area equals impulse. Remember, there was one more thing that I wanted to be so automatic. Area equals impulse for a force versus time graph. The other thing that was so automatic was? Okay, yes. The little corny little saying, though, right, was I don't like funny angles, right? Those should be automatic. Now, that doesn't apply here, obviously, right? It's going to apply later on. but we want those both to be just automatic when we see something, just to automatically go there. Now, Marty, the other thing we should do is what? Yes, absolutely check the axis. We should do that for any graph, including a force versus time graph. You can see here, though, that I do have seconds and I do have newtons. So I'm good as far as that goes. That won't necessarily be the case tomorrow. I mean, you're going to get a force versus time graph on the test tomorrow. You know you are. Right? I don't think I'm giving anything, any kind of state secrets away by telling you you're going to get a force versus time graph. It may or may not have standard units. The question, I would suggest, would be easier than this one actually tomorrow. It's easier than this question. It may or may not have those standard units. Just watch out for that. Now we want to find the velocity of the toy car after 5 seconds. If it starts at rest. Okay, it starts at rest. That's good, VI is 0. Now, the first thing we do is that whole area is equal to impulse thing. And this is a little bit tricky to find the area of, to be honest, because this number here, some people pointed out to me that this number is kind of icky. You don't have those vertical axes, or those vertical grid lines, I should say. That's not going to happen on the test, right? This is my Excel graph, and it didn't even occur to me to put the vertical grid lines in there. Because of that, though, I was pretty flexible in the answer you got. Okay, if you were off by what I had, up by a little bit, I was okay with that as long as it was clear that you did it right. Okay, if you interpreted this number a little bit differently than I did. All right. Area equals impulse. I'm going to break this down into a triangle. I'm going to break this down into a triangle, this into a rectangle, and this into a triangle. Okay? Now, this is a little bit icky. To be honest, I hadn't intended on doing this. It's just one of those things that happened, but oh well. The area of the first one is 1/2 base times height. What's the base of the first one? Looks like this would be about 2.5. So this looks like about 2.75. Halfway between 2.5 and 3, about 2.75. Again, if you were off a little bit on that, that's okay, because that was my fault with the way that I plotted that graph. But the base is not 2.75. A number of you did that. The first time I did it, I did that. The base is not 2.75, but rather it's 1.75. How come? How come? It's 1.75, Haley? Yes, it starts at 1 second. It's going from 1 to 2.75, which is a base of 1.75. My height is 10. Now, you could have also broken that down, as some people did, into 2 triangles. I don't want to do that because I don't need to. But you'll still get the right answer if you do. Area 1 ends up being 8.75. Okay, area 1 is 8.75. Area 2 is also 1/2 base times height. The base is from 2.75 to 3. That gives me a base of 0.25 seconds and a height of -4. That gives me an area of negative 0.50 Newton seconds. How come it's negative? How come it's negative? Because it's below the x-axis, right? Area 3, this one's a little bit easier because it's just a rectangle, but it's also below the x-axis. We're going from 3 to 4. The base is 1. The height is -4. -4 Newton seconds in area 4. Area 4 is 1/2. The base is 1 again from 4 to 5, and the height is still -4. So that gives me -2 Newton seconds. Now we've got to add these up. And when we do, the total works out to be, I scribbled some things out here because my original key was, I made a mistake. I put 2.75 here, and I can't read my writing right here as to what this is supposed to be. 8.75 minus 0.5, 8.25, 4.25, 2.25? 2.25 Newton seconds. I'm going to make that a little bit neater on my key here now. Well, that's the area, that's the impulse, but we're looking for the velocity after 5 seconds. So let's say delta P is equal to m times delta V. Delta V is equal to delta P over m. Delta P is 2.25 Newton seconds. And the mass here, be careful, is 0.075 kilograms. 75 divided by 1,000, 0.075. If you have trouble moving the decimal place over, just literally in your calculator, put 75 divided by 1,000, okay, which is going to give us 0.075. Solve for that, it works out to be 30 meters per second. Now, that's my change in velocity, but if my initial is 0, and I'm looking for final, then my final is just the same as my change, right? If my initial is 0 and I change by 30, then my final velocity would be 30 meters per second. So that's my answer for the 3 points. Good? Yep.
That little girl is pushing the little toy car insanely fast.
Yeah, she is. She's going pretty fast, yeah. But you know what my original answer was? My original answer was 97 meters per second. And to be honest, that's what actually caused me to go back and check and catch my mistake right here. I had originally said 2.75 seconds there. And 30 meters per second is still probably unrealistic, right? But 97.5 clearly is unrealistic. So that was enough to make me go back and check and find my mistake with 1.75 or 2.75 versus the 1.75. But you're right. On a test, you probably would get something a little bit more realistic than that. That's not impossible.
Yeah.
Well, she's pushing it on her own. It probably is impossible. Yeah. And she's fast. Usain Bolt, do you know how fast his peak speed is? His peak speed is about 48 kilometers per hour. When he's running his 100, when he's running the 100, at about the 60 to 70 meter point, he's not running that fast for very long, but at the 60, 70 meter point, he's running about 48 kilometers per hour. Which is, when you think about that, when I ride down Fountain Tower Hill on my bike, I get going about 50 kilometers per hour, and I'm scared to death. He's running that fast. This girl probably isn't going to be running at 100 when she's pushing a toy car, but. No, Shea Weber could shoot the puck at 100 miles per hour, which is 160 kilometers per hour, but.
Yeah.
Okay, but still pretty fast. She's one strong girl. Yeah. Okay, number 4. 85 kilogram football player running 6 meters per second to the east collides with a 90 kilogram football player running at 7.5 meters per second to the west. Two players head off as one object after the collision. What velocity do they head off? There's a question on tomorrow's test where you've got something like this, like a really straightforward question like this. Really straightforward. Like if this is a really straightforward question, right? The only thing we got to watch out for really is the whole east and west thing. And that's exactly what you got to watch out for tomorrow on that question. It's early on in the test too. Like build up some equity by getting those first few questions correct, right? Nail this question, but make sure that you pay attention to I don't know whether it's east and west or north and south or right or left, but two different directions, right? One of them positive, one of them negative. Let's write down some givens here. Let's call M1 85 kilograms. Some velocity is 6.00 meters per second. Can you tell me what that is? V1 or V2? That's V1. Object number 1, the 85 kilogrammer. Is that V1I or V1F? Initial or final? That's initial, right? Before the collision takes place. Now my 90 kilogram football player is my second object, M2, And his initial velocity, v2I, is, we're going to make it negative 7.5 meters per second. Good? Negative? Because I'm making west negative and east positive. Now, these are standard units. If they weren't, let's say I had grams or kilometers per hour, could I keep it? With conservation of momentum, you can keep non-standard units as long as you're consistent in the question. If you're not comfortable with that, just convert. This is the first question on this assignment that you can do that. All the rest of them, you must convert to standard units. But here, you can actually keep it in non-standard units because the units cancel. Again, if you're not comfortable with that, just convert always, because converting always works. What are we looking for? We're looking for VF, right? I'm going to say PI equals PF. Remember we said you can use impulse for this if you want to. I wouldn't recommend it. But if you do, you have to do impulse of one object at a time. Pick the 85 and go with it. Or pick the 90 and go with it. One object at a time. Whereas conservation of momentum, we deal with both of them at the same time. M1 V1I plus M2 V2I equals MVF. Now, I should have said, what's the velocity immediately after? Why immediately after? Why do we want to know how fast we're moving immediately after, not 10 seconds after? Yeah. Yeah, like other things are going to apply, right? External forces are going to apply. We don't have an isolated system if it's, a minute and a half after the collision. We always have to have an isolated system. What is an isolated system, by the way? A collision, sorry, a system, not a collision. It's a system in which we have no external forces, right? And if we're looking at immediately before and immediately after, we don't, for all intents and purposes, have any external forces. Okay, let's sub in our numbers here. 85 times V1I is 6 plus 90 times negative 7.5 equals, the total mass here is 175 times VF. Now, I'm going to go through the math with you here. Hopefully, you can do this on your calculator yourself, but if not, then follow along with me here. 85 times 6, I'm going to press equals. I'm going to add to that brackets 90 times negative 7.5, bracket, negative 165, and then let's divide that by 175. Gives me a value of negative 0.943. Now, a lot of times they'll ask you for this as a numeric response question in scientific notation. This would be, in scientific notation, 9.43 times 10 to the minus 1. Now, if they're asking it as an A decimal B C times 10 to the negative D question, the answer would be 9431. If they're asking it as a B times 10 to the negative W question, the answer would be 9.43. Got it? Okay. Now, I told you guys that I'd be flexible if you expressed it wrong. Okay, I'm going to score these. These get scored by scanning them, so it'll automatically get marked wrong if you bubble it in wrong. But if you show your work, then we can have a little conversation when you notice that, oh, I did this right, but I just expressed it wrong. We can have a conversation, and I'll fix that up for you if that's the case. What I won't fix up, be careful of this, if you said 9.44, because that's a mistake, right? You rounded wrong if you say 9.44. I'll fix up expressing it wrong. I won't fix up rounding it wrong. Okay? All right, number 5. 1,000 kilogram car traveling north, 36 kilometers per hour, collides with a 1,200 kilogram car traveling west at 54. Right away, we see north and west in the same question, which means we've got to do what? Yeah, yeah, and then the x and y components, right? Every single time, the x and y components. So let's draw a picture here. Let's draw a picture. We've got 1,000 kilogram car traveling north at 36 kilometers per hour. We've got a 1,200 kilogram car traveling west. We'll call that car number 2 at 54 kilometers per hour. When I did my answer key originally, I didn't convert. I left it as kilometers per hour. Can I do that? Yes, because there you cancel. Most of you, I noticed, did convert to meters per second. So let's do it that way. Even though that's not what I did on my answer key, let's do it that way, the way that you guys are more comfortable with it. 36 kilometers per hour is 10 meters per second. 54 is, I believe it was 15, isn't it? 15 meters per second. We divide by 3.6, right? The record is going to go off here somewhere, right? So let's go x component, y component. Let's say x, pi equals pf. I'm going to say 0 plus m2v2i. How come 0? Yeah, I mean, you're both right? Like, we're dealing with the x component. Object number 1 is only on the y-axis. So the initial velocity, x-axis there, is 0, and anything times 0 is 0. Mass total times VF. 1,200 times negative 15, if we're doing meters per second. Total mass is 2,200. Now, because I did my answer key in kilometers per hour, I'm not sure exactly what that is. Anybody have that? Meters per second? 1,200 times neg 15 divided by 2,200. Negative 8.18. Thank you. Let's do the same thing for the y component now. We're going to say 1,000 times 10, positive because it's up, plus 0, because object number 2 is moving only on the x-axis, not the y-axis, equals 2,200 times VF. What do we get? 10,000 divided by 2,200, 4 point something it's going to be? 4.54. Thank you. And now let's just draw it out again here. 8.18, 4.54. I'm looking for the velocity, which includes the speed and direction. V would be equal to the square root of all that, which in meters per second, I think, worked out to be, was it 9.36? Meters per second in the angle. I wrote these ones down. 33.8? 33.8? Is that right? Oh, yeah, sorry, I have that scratched out, 29.1, north of west. Yeah, 29.1 is the correct one, yes. Yep. Good there? Now, if I asked for, I could ask you a couple more things here. What's the momentum after the collision? What would you do? Multiply by mass. I could have said, what's the momentum before the collision? Multiply by mass. That gives you the momentum after, but it's the same as the momentum before. Now, number 6 says repeat question number 4. It should have said repeat question number 5, but I made an announcement about that. But with a 1,000 kilogram car traveling at 30 degrees north of east. So we draw this out. We have the 1,000 kilogram car going north of east. at a speed of, what was it, 10 meters per second? Yes, 36 kilometers per hour, 10 meters per second. Now car number 2 was still going to the west at 15 meters per second. I think they're going to head off, I don't know, up here somewhere. But they may actually head off together up here somewhere. We don't know exactly. Right? We don't know exactly. But remember what we said? These givens that we have, like the black lines here, they've got to be drawn correct. Otherwise, you're going to mess up on this question. If your educated guess for the final answer is off by a bit, that's okay. That's not a big deal. Now, what do you see here? This is that second automatic thing that we need to think of here, right? 30 degrees? I don't like funny angles. So we take the 30 degrees off to the side, 10 meters per second, and we break it into x, and we break it into y. The x component is found by cosine, and it should work out to be 8.6603, I think it is. And the y component should be 5.0 meters per second. And then we say x and y. Now, what we could do actually is replace this, right? Redraw this if you want to. Pi equals Pf. I'm going to say M1V1I plus M2V2I equals M total times Vf. M1 is 1,000. 1,000 times 10. The x component. No, it isn't. That's not 10. What should it be? 8.66, right? Plus M2, which is 1,200 times V2I, negative 15. Don't forget the negative in there, because it's to the left, equals the total mass of 2,200 times Vf. Let's do this on our calculators as well here. Let's say 1,000 times 8.6603. I'm going to add to that bracket 1,200 times negative 15. Now let's divide that by 2,200. Gives me a value of negative 4.25, negative 4.2453. Did I guess correctly here? Is the final velocity to the left? I said it was going to be to the left. Sure enough, it is. Y components, same deal. We would say for this one, 1,000 times 5, the y component of that original 10 meters per second, plus 0, because that second object has only x momentum, equals 2,200 times Vf. So this is going to be 5,000 divided by 2,200, 2.2727. Is that right? It doesn't actually ring a bell, but is it right? Yes? Okay. Now we just combine them, right? We have 4.2453. We have 2.2727. And we solve for v there in the same way as we always do, right? I think, again, I did this in kilometers per hour, but I think it was 4.83 meters per second, and my angle was 28.2 degrees north of west. Good. And then finally, the last question says, determine mathematically whether the collision in question number 4 is elastic or inelastic. It was supposed to say number 5, but I wasn't worried whether you did 4 or 5 for this, because the method that you would use, the rationale that you use was exactly the same. And the result, the numbers are different, but the result that you would get would be exactly the same as well. In the end, question 5 and 6, actually 4, 5, and 6 would all be, we know right now, would all be what? Inelastic. And you know that because they stick together, right? When they stick together, it's got to be inelastic. But it does say determine mathematically that it would be elastic, whether it was elastic or inelastic. So we know what we should get. Now let's get that mathematically. I'm going to go with question number 5 here, because that's what I meant it to be. No, I'm not. I'm going to go with question number 4. Even though I meant it to be number 5, it said number 4, so let's go with number 4. But the method that we're going to use is going to be exactly the same. We're going to say EKI, the initial kinetic energy, is 1/2 m1 v1I squared plus 1/2 m2 v2I squared. It doesn't matter whether we're east and west, like in question 4, or whether we're north and south, east and west, like we are in question number 5, or in question number 6 for that matter, whether we're at 30 degrees north of east. It doesn't matter about the direction, because kinetic energy and speed are scalar. Right? So let's say 1/2 of m1, which was 85 kilograms, if we're referring to number 4. v1I is 6, 90 kilograms. v2I was negative 7.5, but we're going to make it positive 7.5 because, again, of the scalar nature of speed and kinetic energy. Let's calculate that. Let's say 0.5 times 85 times 6 squared plus bracket 0.5 times 90 times 7.5 squared, and the bracket gives me 4061.25, or 4.06 times 10 to the 3 joules, to 3 significant figures. Now, we know that we should get a final kinetic energy that is less, right? It should be less. Never going to be more, either the same or less, but of course when they stick together, we know it's going to be less. So let's find that now. Mass total times VF squared. The total mass is 2,200 kilograms, and the final speed we had calculated to be 0.943 meters per second. So 0.5 times 2,200 times 0.943 squared gives me a value of 978. To 3 digits, 9.78 times 10 to the 2 joules. So we would say clearly kinetic energy was lost, 4,000 down to 978. Therefore, it would be inelastic. All right? Again, I told you that you should expect to see on your unit test and probably your diploma exam at least one question on elastic and inelastic collisions. The one question that we can be almost assured of getting on tests and on diploma exams is the question that basically asks you for the difference between elastic and inelastic collisions. is kinetic energy conserved? Is momentum conserved? Like it's almost a guarantee that you get that. And then maybe you get one where you have to calculate as well, although those tend to be a little less common than the qualitative ones. You okay with this? How do you feel about the assignment? Good. How do you feel about the test? Good.